Scott here. I've got myself a new track bike, a 2010 GSXR 750, and one of the things I've done is I've purchased the full Bazzaz system for it. I'm a big fan of the Bazzaz fuel management quick shift traction control system, but what I'm not a big fan of is the pricing for the three key accessories, being the map switch, the traction control adjust switch, and the traction control active light. I mean, you're paying around $300 for things that are very, very simple to make yourself. So that's what this video is about. It's split into two parts. So part one is how to make your own map switch and your own TC active light, and part two is how to make the traction control adjustment switch. Total cost for the whole thing is around $20 odd to make those three things. So I hope you find this video helpful. So there's the jumper connection on the Bazzaz fuel harness, and that's how you get your map 1 and map 2. So when those leads are connected, that's map 1. When they're disconnected, that's map 2. So what does that tell you? You just have to put a switch in. You can pay $60 or something for the switch with the plug on it, when all you've got to do is put your own switch in. So I've got a cable here, a bit of twin core auto cable. I'll solder those onto those two ends there. I've run the cable along the left hand side of the frame there, through to the front, and then it comes up, and here's the surplus here. So I'll connect a switch onto the cable, and I'll make myself a little plate to bolt on here, which will have the switch on it and also the traction control adjust. There's the solder joints with some heat shrink tubing on them. So here's the small alloy panel I've made to take the map switch and the traction control adjuster. The small switch there I purchased from the local electronics shop for about $2.50, and now I'll just solder these two wires onto the terminals. So that's the soldering completed. Now I'll wrap that with a self-sealing silicone tape. So there's the completed map switch wrapped with silicone tape. Here's the tape here. This stuff's very, very handy. It actually amalgamates when you wrap it, so it sort of becomes one. So handy stuff to have. So the next thing we're going to do is set up our own traction control active LED. Now you can buy the the LED and the harness for about $70 odd, or you can make your own for about $5 to $7. So what I've done here is this yellow wire, I've run that along the left hand side of the frame through to the front of the bike and up behind the instrument cluster, so that's just hanging free at the front at the moment. Now the way the traction control active light works is there is a terminal that's switched to ground, so it's switched to the negative every time the traction control is triggered. What I did is I just took my harness here down to my local electronics parts store and showed it to them, and they gave me a terminal that I can slip into here that fits this connector. I got a little pack of them for $1, and there's about 10 in there. So this is what I purchased for about $1, and you just have to snap one of these off and put it onto the end of the wire, and I'll show you how to stick it into the connector. And I also bought at the electronics parts store a 10mm bright green LED, and that was only a few dollars. On the ignition harness, it has this connector on the end, which is the smaller of the two connectors, and the pin in here that's grounded, that's grounded or switched to earth when the traction control is activated is terminal number 15. Now, on the back here they're numbered. This one here is number 10 and that's number 18. So we go, so that's 10, 11, 12, 13, 14, 15. So number 15 is where we want to connect this yellow wire. So it's the one next to the brown wire for reference. And then the next terminal over, number 16, is a constant 5-volt power supply, which is available for you to use to power up your LED if you wish. That means running 2 wires down to the front of the bike. I've elected to use a 12-volt ignition switch power supply down the front, so I only have to run a short wire from below the instrument cluster, and I just elected to do that because it's easier, it's less wires to run. So what we have to do now is we've got to get this yellow wire into terminal 15. So to do that, we need to dismantle this, and we want to take the orange cap off the end here. You just have to push these little tags in, and that will sort of release each end, and you can slide it off. So that's one end. Yep. So we take that out and turn it over, and we need to get the backing plate out, and you can just use your little pointy tool here and you can lever it up. It sort of unclips. It's one end out. That's the second end out. So you pull that back as far as you can. And then inside there is a silicon rubber sealing grommet, so you can just lever that out. And just slide that back as far as you can as well. And now we can see inside here, and it's next to that, next to the brown wire. So here's the yellow wire. Let's first of all, we've got to thread it through the backing plate here. So through number 15. So we'll get that through there, and then also push it through the adjacent hole in the blue rubber grommet. There we go. So we can see that coming through, and now I just have to put that little tiny terminal onto the end. Okay, the little terminal's on here, and I've soldered it, so now I just have to push it into the socket in the back here. You should hear it click into place, and I'll just use the little pliers here to grip the wire and push it in, and you should hear it click. Yeah, there it is. So that's now held in there securely. Now, just need to straighten the wire out, slide the rubber grommet back in, just make sure that it's in its seat, and then slide the backing plate on. Like that. And then the little orange front cap goes on. And that's it. Now it's ready to plug into the Bazzaz control unit. So here's the LED I purchased to use as my traction control indicator light. Now you need to know the specifications for the LED. Now the one I bought, here it is here, so it operates on 3.1 volts, 20 milliamps. So you need to know those two numbers, the voltage and the milliamps. Now most LEDs operate on, sort of around 2.5 to 3.5 volts. So what we need to do is put a resistor in line with the power supply to drop the voltage down to 3.1 volts from about 13.5, because remember when the engine's running and the alternator's going, you're putting out around 13.5 volts. So let's just make a note of this. So the LED is 3.1 volts and the current draw is 20 milliamps. And the voltage that we're going to supply to the LED is, we'll say, 13.5 volts. So we need a resistor to use up the difference between 3.1 and 13.5. So the voltage we need to drop is 10.4 volts. Now, V equals IR, that is volts equals amps times resistance. If we want to calculate the resistor that we need, therefore R is equal to V divided by I, so it's the volts divided by the amps. So in this case R is going to equal 10.4 volts divided by 20 milliamps, because that's what it draws. So 20 milliamps is 0.02 of an amp. They're amps, they're volts. So the resistor is 10.4 divided by 0.02 is 520 ohms. So we need to put a 520 ohm resistor between the power lead and the positive lead of this LED, and then that will drop the volts down to 3.1. Now I happen to have a 560. I've got a 560 ohm resistor here, so I'm going to use that. That's close enough. It doesn't have to be exact. And if it's a little bit more, that's probably a good thing. I'm just soldering the 560 ohm resistor onto the 12 volt power supply wire. So with the LEDs, the longer leg is always the positive, so that resistor needs to go onto that leg there, but I'm going to trim them both down a bit because they're far too long. Then I'll leave the positive one just a touch longer so I don't get them mixed up. Now the yellow lead here, which is the negative side, that can just get soldered directly to the negative leg of the LED. I'd already put some heat shrink tubing on here, so I'll just slide that over these. So now what I do is wrap this with just some normal insulation tape. And then some of this self-amalgamating slip. The last thing is let's get some heat shrink tubing and put it over here so that it just clamps around the base of the LED. That's the completed light, and what I'll do then is I'll just put some Velcro on it and that'll stick on here. Let's test this out. I've put a piece of wire into terminal 15 and I'll turn the key on. Now when I earth this, the LED light should come on. So that's what happens when you're riding, it'll flash on and off as the TC switch is on.